You ever wonder how your computer can be streaming music, downloading a massive file, and letting you browse the web all at the same time? Especially when it might only have one processor core doing all the work. It feels like some kind of magic, right? Well, today on The Explainer, we are pulling back the curtain on this clever illusion.
I mean, really think about it. How can one single brain, the CPU, be focused on so many different things at once? The secret is, it's not. It's actually a trick, a really, really fast and clever one that's at the very heart of pretty much every modern operating system. All right, to really get our heads around this illusion, we need to meet the star of our show. It's something called a process. So, what is a process? Simple. When you double-click an icon, say for your web browser, the operating system grabs that program file, loads it into the computer's active memory, the RAM, and starts executing its instructions. That living, breathing, running program, that's a process. And here's probably the best way to think about it. A program is like a recipe just sitting in a cookbook on your shelf. It's just a passive set of instructions, right? But a process? A process is the actual act of cooking. It's dynamic, it's using ingredients from the pantry, that's your RAM, and it only really exists for as long as it takes to make that dish. Now, a process actually goes on quite a journey during its very short life. In fact, its path looks a whole lot like a dish moving through all the different stages of a really busy restaurant kitchen. First up, it starts in the new state. This is the moment the operating system creates it. Our chef has just picked out a recipe to make. Next, it gets loaded into memory and moves to the ready state. All the ingredients are prepped, and it's just sitting on the counter, waiting for an open spot on the stove. Then, the moment the scheduler gives it the green light, it's running on the CPU. The dish is finally cooking on the stove. But what if it needs to grab something that takes a while, like data from the hard drive? Well, it enters the waiting state, moving off the stove so another dish can start cooking. And finally, once its job is totally done, it's terminated. The OS cleans up all its resources, and the dish has been served. Okay, so you can have hundreds of these processes, all in these different states, all at the same time. How on earth does the operating system keep track of everything without getting completely overwhelmed? Well, it has this brilliant little tool called a process control block, or PCB. Just think of it like the head chef's master notebook. For every single dish that's being made in that kitchen, there's a dedicated page of notes detailing everything about it. So what kind of stuff is on that page of notes? Well, the PCB stores the process's current state. Is it running? Is it waiting? It remembers exactly which line of code it was on, all of its current data. It's basically a perfect snapshot of that process at any given moment. And that snapshot is absolutely crucial for what comes next. Because the ability to pause one process by saving its snapshot and then immediately start another one, that is the core superpower of multitasking. But, and this is a big but, this superpower isn't free. This action is called a context switch. It's the time and effort the operating system spends carefully saving the entire context of the current process into its PCB and then loading the context of the next process from its PCB. It's literally the time our chef spends putting away the recipe notes for one dish and pulling out the notes for another. And during that switch, no actual cooking is getting done. That's overhead. And all of this brings us to the real brains of the operation, the scheduler. This is the part of the operating system that acts like that head chef, constantly making the critical decision of which process gets to run on the CPU and for exactly how long. So what makes a scheduler good at its job? It's not just picking processes at random, that's for sure. It's actually a super sophisticated manager trying to juggle a bunch of competing goals at the exact same time, all to make the whole system feel quick and responsive to you. And look, this is a really delicate balancing act. The scheduler wants to keep the CPU busy all the time and finish as many jobs as possible. But at the same time, it has to make sure that when you click on a button, the system responds instantly. A lot of these goals actually conflict with each other. So to try and pull off this amazing balance, schedulers use different strategies, or algorithms. Let's take a look at two classic approaches to see how they try and solve this puzzle. Okay, the simplest strategy is exactly what it sounds like. First come, first served. Processes get in line, and the CPU just works on them in the exact order they showed up. Sounds fair, right? But it can lead to a massive problem. That problem is called the convoy effects. Just imagine a huge, long process, like rendering a video, arrives first. But right behind it in the line are a bunch of tiny, quick tasks, like registering your mouse clicks. Well, with first come, first served, all those tiny tasks have to wait for that massive video render to finish. It's like a traffic jam, and it makes the whole system feel slow and totally unresponsive. So, clearly, we need a better way. And that brings us to a much, much more responsive strategy called round robin. Instead of letting one process run until it's completely done, the scheduler gives each process a tiny, equal turn on the CPU before quickly moving to the next one in line. That little slice of time is called a time quantum. And when I say tiny, I mean it. We're talking just a few milliseconds. By rapidly cycling through all the waiting processes, round robin makes sure that even if a huge video render is chugging along, your web browser and your word processor still get their turns, which keeps the system feeling interactive and super snappy. Okay, let's tie all of this back to you sitting at your computer, clicking your mouse, typing on your keyboard. The reason? The only reason you can type in a document while a file is downloading and music is streaming is because a brilliant round-robin style scheduler is performing thousands of those context switches every single second. It's jumping between your word processor, your download manager, and your music player so incredibly fast that to our slow human brains, it feels like they're all running at the exact same time. It's an illusion. It's this beautiful, high-speed dance of managing processes, performing context switches, and intelligent scheduling that creates the powerful illusion of doing everything at once. And it kind of leaves us with a final thought to chew on. As our devices, from our phones to massive cloud servers, get more and more complex, what are the next great scheduling challenges going to be? And what clever new strategies will we invent to solve them?